the question is asking what is your average speed in feet per second, you are going to have to go through a series of unit conversions, basically a series of substitutions to actually get to your answer, because you're given dimensions were miles and hours, and your end result will be in feet per second. So that's really what a composite function is. It's a series of substitutions with functions. Okay, so let's go basically and start with the first example. Now the first example has f of x is equal to the square root of x, g of x is equal to x minus 1, and it wants you to find f composed by g of 2 for this problem. Now remember, you can use or rewrite f composed by g of 2 as f of g of 2. Remember, the same order as what the left hand said or looked like will be the same order as what the right hand will look like. So that's what I'm going to do. I'm going to rewrite this. So let's go ahead and open up a new document. So this is the document that I'm going to use. And the rewritten form of f composed by g of 2 is really the same thing as saying f of g of 2. Now remember, we always want to follow order of operations, and PEMDAS always states that the P is parentheses. So we're going to start with the inside of the parentheses, which basically says g of 2. Okay, so we're trying to find g of 2. So what does this mean? This means you're going to go to your g function, which is right here, and you're going to plug in 2 every time you see the x. So here we go. I see an x, so this is now becoming 2 minus 1, and what's 2 minus 1? It's 1. Alright, so now this has just become f of 1. Now what is this saying? This is basically saying you're going to go to your f function, and wherever you see an x, you are going to plug in the value 1. So here we go. If we plug in the square root of 1, you get 1 as your answer. So that's what we get for this part. Now, whenever we're doing composite functions, we don't need to worry about positive plus or minuses when we take the square root of numbers. So for this case, it's going to be positive 1. Okay, let's move on to the next example. And the next example is basically saying you have f of x is equal to x plus 2, and g of x is equal to 4 minus x squared. Now this time we're going to have to find two things. We are going to have to find the regular form, f composed by g of x, and now we're going to find the backwards form, which is g composed by f of x. Again, same process. In order for us to rewrite it, it's going to look exactly in the same, or it's going to appear in the same order the letters look like currently. So this will be f of g of x, and this down here will be g of f of x. So let's go ahead and do that right quick. So let me just replace what we have here. Okay, so those are my new functions. And now we're going to go ahead and work on the first one. The first one says can be rewritten as f of g of x. Now, I have the g of x highlighted because, again, PEMDAS says we have to start with the parentheses. So that really says that we are going to substitute the inside with g of x, which by coincidence we know what it is, and that is 4 minus x squared, which is great. Okay, so now we've substituted the g of x. That means we have to take care of this part here, which says go to your f function, and wherever you see an x, you are going to have to plug in 4 minus x squared. So you're going to have to input 4 minus x squared. Okay, so when we do that, let's follow the process. I see an x, so I have to substitute 4 minus x squared. But let's not forget about the rest of my function. The rest of this function says you have to also add 2. Okay? So now we combine like terms and we get 4 plus 2, which is 6, and then the rest, which is minus x squared. So that will be my official answer for f of g of x. Okay, now we are going to start with the flipped part of it, which is basically g of f of x. Again, we're going to follow order of operations. P stands for parentheses, which means this time we are going to replace the inside with f of x, which by coincidence we also know what that is, and it is actually x plus 2. Now, this is telling us we have to go to our g function, which is right here, and we're going to have to substitute or input x plus 2 everywhere we see an x. Okay, so let's follow that process. I see the 4, so I don't need to input anything, minus I see an x. That means I have to replace it now with x plus 2. But go back to your g function, and it also says you have to square it. Okay, so let's analyze what we have going on here. We're going to have to square this by either FOILing or using the shortcut that I taught you, and then distribute the negative inside. So let's do that. So we're going to go ahead and continue from the bottom, and we are going to say 4 minus parentheses. Let's go ahead and do the shortcut. Square the first, so we get x squared. Multiply the first times the second, so x times 2 is positive 2x. Double it, and it's 4x. And then square the last. So what's positive 2 squared? And that's 4. Perfect. Okay, so then after that, we're going to go ahead and distribute the negative. So when we do, we have 4 minus x squared minus 4x minus 4. And if you notice, what happens to your 4's? They cancel out, leaving you only with your official answer, which is negative x squared minus 4x. That is perfectly fine to leave like that. Okay, moving on. So again, those are the answers, negative x squared plus 6, and if you can see it at the bottom, okay, at the bottom, you should get negative x squared minus 4x, which we do get if you can see it down there. Okay, so moving on to the next question. It says, find the sum, difference, and quotient of two functions, and you have two functions there. F of x is equal to 2x plus 1. G of x is equal to x squared plus 2x minus 1. It's asking you to find f plus g of x, f minus g of x, f divided by g of x. Now, you can apply this and rewrite it into a form that's easier to read. So let's go ahead and just start in a new document for this one so you can see what I mean. So I've written down the f of x and g of x functions, and I've rewritten the sum. Basically, what you've seen on the left-hand side from the PowerPoint can be rewritten as this. So basically what happens is you take your f function, you take your g function, and the sum is you add them together. So let's do that. So we have our f function, which is 2x plus 1. And then you have your g function. We're going to add them together, which is x squared plus 2x minus 1. And all you're going to do now is collect like terms. So once I collect like terms, my x squared cannot be added to anything. My 2x's add up to be 4x, and my 1's actually cancel out. So for this one, I am left with x squared plus 4x. Now let's move on to this part, which says f minus g of x. I'm going to rewrite that into something that's a little bit easier for you to read or look at. And that's the exact same way that I did the addition one. But instead of addition, I'm just going to change that plus sign to a minus sign. And again, I'm going to do the exact same thing. So I have my f of x, which is right here, 2x plus 1. Now here's the tricky part. Minus parentheses, then you have your g of x part, which is 2x squared, or x squared plus 2x minus 1. So I'm going to go ahead and do that. Now that's tricky because now you have to actually distribute the minus to each one. So you get equals 2x plus 1 minus x squared minus 2x and then plus 1. So now we collect like terms, and it seems like we are still left with negative x squared. So that one's off to itself like this. Our two x's actually cancel away, and we're left with just the 1 plus 1, which happens to be positive 2. So we're left with negative x squared plus 2. Okay, then the next part is to say we're actually going to answer this one, f divided by g of x. F divided by g of x. So that's the same thing as saying, basically, let's rewrite that one. That's the same thing as saying f of x over g of x. And that's really simple because all I do is now I take my f of x, which is 2x plus 1, and I take my g of x, and that's going to be my denominator, which is actually x squared. And I get that as my solution for the last one. If I can't do any factoring and canceling out, then I would just leave it like that. So you're left with a rational expression for that one. The same thing applies for multiplication. However, if you realize if we were to do multiplication, we would have to say 2x plus 1 times x squared plus 2x minus 1, and we would basically have to FOIL everything out. So they do get a little bit messy. We will do some of those when I actually am back in class on Monday. So don't think you won't get away from not doing them, because we will, and we will work with actually some really ugly ones, just so you can get in the habit of multiplying and constantly adding and collecting like terms. Okay, at this point, we are done with the new lesson. Again, like I've said, you are responsible for it. I should be arriving in a little bit to distribute the quiz, and being there until you take it and finish it. Also, please remember that your homework is due on Monday. I've gone over number 1, so I'll go over it again just in case I have people that didn't listen. I have number 1 right there. We've answered it. You should be able to do number 2. You should be able to do number 3, number 4, number 5. Number 6 is the only one that I will allow you to do on the worksheet itself, and I highly suggest that you do it in different colored pencils or pens or markers, whatever you're using. And then number 7, and I told you to eliminate D, F, and H. If you have any questions in regards to the homework, you know how to reach me via my website. You can always email me. I'm always good at returning emails, but it is your responsibility to finish the homework. All right, so after that, let's go over the schedule for next week. I'm going to finish composite functions on Monday by doing a bunch more of examples. I'm going to do inverse functions as well as one-to-one functions on Tuesday. We will review on Wednesday, and we will test on Thursday. So it seems like we are on schedule with our calendar.